Hello, everyone, and welcome to our Ask the Expert session of Smart Data Pipelines to Azure. My name is Matt Basile. I'm a program manager on the Azure Synapse team, and today we're joined by Joby and Tom from StreamSets, which is a data ops startup based out of San Francisco. And today we'll be talking about the different problems that we see in modern data applications with a lot of their data ops and data movement tasks. And how you can use StreamSets, Synapse, and other platforms in Azure to help solve a lot of these problems. So Joby and Tom, do you guys want to start by introducing yourselves?
Hi, thank you, Tom. Thanks, Mike. Thank you for inviting us and hosting this discussion. These are challenging times. I want to give a special thanks to everyone who's working hard to keep us all safe. I run the BD and the cloud business for StreamSets. We are a co-sell prioritized Microsoft startup, and looking forward to the discussion. Tom?
Hey, my name is Tom Ganka. I'm a cloud solution architect at StreamSets. I've been in the data engineering and data architecture space for over 10 years, and I have a passion for making data more accessible, developing data products, and driving organizational change through data. So I look forward to today's discussion.
Thanks so much. So we'll start by taking a look at StreamSets more specifically. And so Joby, if you could actually walk us through, what StreamSets is, maybe talk about some of your differentiated offerings, and as well as kind of moving into what are some of the gaps you see in existing ETL tools?
Absolutely. So StreamSets is a modern data integration platform for data operations or data ops. We basically help enterprises flow traditional streaming or big data to cloud in an agile and a resilient way. We do this by basically instrumenting, automating, and monitoring every data pipelines which we bring in, which allows us to build this continuous design, deployment, and operation of data flows. This enables us to do things like DevOps or CI/CD type of data flows. And we do this all in this context of what we call as data drift. Data drift is something what we define it as the small or large changes which happens onto the data structures, which could be basically think of adding a field, moving a column, or basically the semantic meaning itself changes. Think of something like IPv4 to IPv6, where the field remains the same, but the meaning itself changes. Now, when this happens, it basically puts a whole costly maintenance burden and also puts the whole question mark on the insight you're trying to build because you're not very sure of the data quality of the data you're actually working with. And we address that problem head on. So basically, it's not just about connecting the data from one point to another point, but it is also about taking an operational approach to the data flow. And data flow is not under one control. The data are all over the place. Basically, you have data coming in from legacy applications, web traffic, sensors, SaaS applications. And a lot of them are not under the single control of a central IT, but all these data needs to be assembled back as you're trying to build new applications or new insights. But on the other side, these same data platform users or the data engineers are under pressure to put out this data in a consumable form in almost in a real-time fashion. So this is an ever-changing field where operations become a critical part of connecting the data from one endpoint to another point. Now to answer your question around ETL tools itself or the other tools which are there are various tools out there for data engineers to use, ranging from like traditional ETL tools for doing simple data loading or doing something like hand codings and things like that. But they all make life harder for the data engineers. They either require a lot of specialized coding skills, or they are very simplistic. They can do perhaps load the data once, but not fit for building data pipelines that can operate on an ongoing basis. And almost all these tools which are built on hand codings are a little brittle. Basically, they do lead to brittle mapping, as I described the data drift, where things change. These pipelines become obsolete as soon as you put them in the production. And those big, when there are big replatforming projects, when there are infrastructure changes, when there's a shift happening to the cloud, it means you have fundamental rewrites of this pipeline, slowing adoption, or overall delays in the big data and the AI/ML projects itself.
Thanks so much. And I definitely what you're saying about these big shifts. That's something we see a lot with Synapse, of course, is these big lifts and shifts of data warehouses. But exactly that data drift can almost be more dangerous to catch because it's those small incremental changes that can almost be harder to notice sometimes, but of course can cause big problems as that data flows down that pipeline. And so you talked about data drift. You talked about a few other topics. Can you talk about these as trends? And what you see as kind of big trends with modern data applications? Do you see different sets of problems occurring at different levels, like SMB or enterprise? And then once again, of course, going into how you can help to address and actually solve those problems you see.
Absolutely. So if you look at like the modern data application, when they get deployed in the real world, they're pretty messy. Be it like building a modern data warehouse on Synapse or Snowflake, or data lakes on ADLS, or real-time streaming applications like cybersecurity or log analytics. They all rely on data. They are coming at various rates. They are very noisy. The cybersecurity data tends to be, a log data tends to be very, very noisy. And they have generally some kind of like, you have to put some kind of a messaging or a queuing layer. So you'll put Kafka or some kind of a message queue or an event hub. And then there is some kind of a speed and a batch layer on the other end. And then there are a mix of approaches. There are ELT, there are ETL, again, all selected based on the ideal application architecture, which fits the need which the engineers are trying to solve. You could end up leveraging Apache Spark for leveraging the power of the compute, or you could go for a ELT type of approach where you're leveraging the cheap storage and then doing the transformations and processing on the side. So very messy, very complicated in the sense that every deployment seems to be very different. And the deployment topologies are also showing up in all combination, be it like Microsoft SQL Big Data Cluster based on-prem deployment, where you are basically leveraging the full power of the SQL and then augmenting it along with the Spark and the SDFS layers, but being driven by the business requirements. In this case, we had a customer, a big bank in India, where compliance and archival requirements were driving data retention on premise for almost 3 years, which was driving the architecture and the architecture choices they were making. But on the other end, teams are moving to cloud native architectures, tackling multi-cloud deployment, be it like cost efficiency or for strategic reasons. Data engineers and data platform owners are stuck in the middle of the storm. They're basically trying to balance it all out. We have customers who had started like 3 years ago by building a fully on-prem Hadoop clusters. Then they transitioned to a Hadoop cluster running on private cloud, running on Azure. And then they migrated all of it to Azure and HDInsight. All of this in the last 3 years. But the key is they kept StreamSets as a glue layer for all their data flows, basically aligning their seamless evolution of the architecture and deployments. And that's the key differentiation for us. We bring in this automation and productivity and time to value type of advantage for people who end up choosing. And that's where our DataOps approach comes in, which provides basically a single pane of glass, a control hub to manage and monitor all the data flows across all pipelines, both on-prem and in cloud, allowing basically this end-to-end data flow operation for the data engineers to deliver the data platforms they are tasked to deliver.
And that single pane of glass can be so powerful. Seeing customers migrate, the ability to migrate, only some of your platform and keep something like that DataOps with StreamSets consistent. It can really help speed up that process because it gives you something consistent to help track that progress, move that data. So that's really awesome to hear. As we move to the next topic, I also want to remind everyone to please continue to drop your questions in the chat as we go, and we'll keep addressing those and answering those as we get later on in the discussion. So you started to mention some different Azure technologies there, things you work with. So Tom, if you wanted to talk about kind of the breadth of Azure technology supported by StreamSets, and in particular, how you integrate with Azure Synapse and maybe just some new things that your team's working on.
Yeah, absolutely. We actually have native enterprise connector specifically for Azure Synapse for ingestion. So this connector provides a lot of different features out of the gate, taking advantage of the great things that Azure Synapse can do. So things like the copy command, right? So we have native support for that. This concept of data drift. It turns out that Azure Synapse actually supports the handling data drift out of the gate, so you don't have to do any extra work as a data engineer or data analyst. In addition to that, we also have performance optimizations like multi-threading support, batch size tuning, or additional connections. So those are some of the things specifically related to the ingestion of Azure Synapse. In addition to that, we also provide an integration directly with Azure Active Directory, right? So giving you some additional security integrations, as well as Azure Secrets integration. On top of that, we also have an integration directly with the DevOps portion of Azure. So Azure Pipelines, we provide a seamless CI/CD integration. On the roadmap, some future things coming down the pipe, we'll be adding direct support for Azure Synapse within our Transformer product for data lake migrations to Azure Synapse. We also be adding SQL pushdown to Azure Synapse, so looking at the Azure SQL layer. And in addition to that, we also will be further evaluating the additional Azure Synapse landscape as it evolves as well.
It's always great to hear that. Obviously, seeing that two tools can best take advantage of the different functionality in each other, things like the copy command, multi-threading, that SQL pushdown. It's always awesome to hear because that just helps more customers leverage the best of both technologies. Kind of touching on that, I think a very common question that we get whenever we talk about honestly Microsoft product and partner. Microsoft's got a very broad portfolio. And that means there's very often things that overlap. So a lot of people would look at this and see that, there's Azure Data Factory already in Azure. There's the Synapse pipelines that could potentially compete with StreamSets. But, we always like to emphasize that it's very often a cooperative rather than a competitive story. So Joby or Tom, if you guys want to touch on how you see customers actually leveraging both these Azure Data Factory and pipeline capabilities alongside StreamSets.
Yep. No, I can start, and then Tom can jump in. Just to close on the previous question around the Synapse integration, but Synapse is one of the platform we integrate with on Azure. We take a whole platform approach or a whole cloud platform approach. So we do integrations with ADLS all across. We do integration with Azure Databricks. We are one of the apps available on the Azure HDInsight. So we take a whole portfolio approach to our go-to-market with Microsoft, and Microsoft is a pretty important partner for us from an integration and for our customers also. Now, coming back to your question around ADF. ADF does a great job. It's good for supporting data ingestion for Azure, data storage, compute assets. It's a great tool for building solutions that fully reside on Azure natively, right? And no question about that. But as I said, the real world is slightly different, or it's a little more complicated. There are data silos everywhere. Specifically, the customers we focus on, which is just like Fortune 500 to Fortune 1000 type of companies, they have legacy mission critical application that can't be just lifted overnight and moved to the cloud. Think of supporting trickle feeding from those live applications like inventory systems, e-commerce sites, etc. A lot of Oracle databases in the wild. While new applications need those data to build new insights and applications, features like Oracle Change Data Capture support without one having to bring in additional tools or to break a bank becomes super critical. And we bring that to the table. That's one of our differentiated value there. We support streaming batch from multi-platform environment with the same flexibility and agility to deploy with the basically whatever the prevailing architecture might be at that time. And the architecture evolved as I mentioned previously. And that's super critical because customers are in this journey as they are moving through various architecture configurations, as they're moving through their journey to the cloud. And goes a long way in the success of the project. In fact, we end up complementing ADF in a lot of scenarios. And just to give an example, Shell is a customer of ours on Azure. One of the biggest manufacturing and energy conglomerate has all kind of data, varying from 7 terabyte subsea inspection ID data to petabyte scale seismic survey data. And also some of these data is coming at a very fast pace. Some of them come at slow rates and things like that. In some cases, they're getting around 100K measurements per minute from the ring, which is coming in. And you basically use a OPCA or a historian connector to get to those data. These cloud-enabled AI platform is enabling all facets of business from like exploration, drilling, manufacturing to safety. They've built this massive platform, Shell.ai, which is basically a company-wide platform to basically use data as a tool to enable insights and drive day-to-day business decisions. Now, it's currently serving around 600 plus data scientists, building predictive maintenance, breakage, safety type of things. Now, they're using StreamSets to get data from the edge using capability like the OPC UA talked about, and use ADF to support serverless execution and data movement natively on the Azure itself. So this is one of the instances where they're basically coexisting, and we are doing it pretty much. They have brought into the whole data ops approach and building the application that way and basically coexisting. And that's where we see our value add on how we come and complement ADF. Tom, you want to add anything else?
Yeah, absolutely. I think I can't stress this enough. It's really about complementing ADF, right? Like Data Factory is the peanut butter, StreamSets is the jelly when you get the sandwich together, right? So we have a lot of companies that are leveraging ADF for batch workloads as well as a variety of other use cases. And then when you think about streaming, Kafka, pub subs, Confluent, all different types of streaming use cases, StreamSets is there for you in cases like that, right? As well as change data capture cases. So basically anything that ADF can't get out of the gate for you, that's where StreamSets comes in to tie it together with a DataOps approach, to tie into the Azure ecosystem with the different tools already out of Azure, to provide that operational visibility and agility for the DataOps team.
And those are all fantastic examples, and I think that's one of the number one reason I love having these conversations with partners is because that's the philosophy in Synapse too, is use the right tool for the job. So if you got to do data warehousing, we're giving you SQL. If you want to do Spark, we give you Spark. Visual, we give you Visual, and it's exactly the same with something like StreamSets. Play to StreamSets strengths, bring it in, and use these complementary tools that each excel in different areas. So thank you so much for all that information. We did have a question come in of what other Azure services or products does StreamSets integrate with. So Joby or Tom, if you want to touch on that, or if it's just easier, if you have a link maybe that you can drop in the chat, we can get that out to all the attendees as well.
Tom,
yeah, I can go ahead and name as many as I can off the top of my head. So
lightning round, you've got 15 seconds.
Lightning round, okay. Azure Data Lake, right? That's a big one. We've got the Azure Pub Sub, or the Azure Event Hub, sorry. So we've got HDInsights, right? We've got Azure Synapse. We have Azure SQL, which is a variety of things under the umbrella under there. And then we also have, those are a couple that I named off the top of my head. Oh, Cosmos DB, that's another one. So there we go, I'll stop with that.
No, thank you so much. And so kind of as we start to talk about all these different products, and I know we talked a lot about the size of the different companies and industries you work with, and same with Synapse. A very common problem is that as your business grows, as your data grows, everything grows with it. Tables, scripts, pipelines can just grow massively, and of course that's a huge management workload for your data engineers, your data analysts. So how do you see DevOps and DataOps practices fitting into these data workflows and data pipelines? And why should developers care about these tools?
Absolutely. All right, I can start, and then Tom, you can jump in.
Yep.
So basically, speed and agility is important. And think DevOps, CI/CD capabilities are pretty much very well proven out in the software development, productivity gains, all the other aspects of it, which has been there forever. All these practices are pretty relevant for data operations and efficiency. And that's how we kind of define the data ops. And we support basically end-to-end data engineering of this smart data pipeline. And as I said, we do it basically by building and monitoring and automation and making it easier to go and operate the data flows itself. We provide things like live topologies, the data flow views, where you can get an end-to-end view of data flow. So you can now look at use cases where How much time does it take for a clickstream data to make it through the event hub to get it to basically HDInsight and then getting archived in some other place? And what are the KPIs across those? So you get a live view of the overall operation of the data flows are going on. This gives you a lot of automation and productivity advantages and a life cycle based approach to managing the data flows itself. Tom, you want to jump in?
Yeah, and I think to add to that, right, like when we were looking at DevOps as this practice that sort of came into play 10, 15 years ago, it really transformed the way that developers and operations teams did work, right? And really what we centered around data ops is we believe that same thing is happening with data, right? There's this change, the sea wave really occurring for data developers and data engineers. And our platform allows for engineers to work with a variety of different people throughout the organization. So they're able to exponentiate the work that they're doing to other developers, to other ETL developers, data analysts, or data scientists, so they can go back and work on the core problems and adopt these additional core technologies, new core technologies that are coming out, right? So this data ops is really around the technologies evolved, and in addition, these data teams are evolving, and we're at the front and center with a platform for that.
Awesome, thank you so much. And we had a viewer question actually come in about, what do you mean by data ops? And so thank you so much for explaining it as a process to managing that, similar to what we've been using for DevOps for years now. So we had a great question that came in, which is, can you explain the measures that StreamSets takes to remain GDPR compliant? And I assume this means for yourselves, but also how you help customers to remain GDPR compliant that are using StreamSets.
Cool. I can take, and then Tom, you can jump in. So various approaches. And again, GDPR is such an ever-moving target that everybody's kind of catching up on how to rightly address it. But we have some fundamental architectural advantage. We basically break our platform into two parts. One is a data plane, and another is the control plane. The data plane part basically does the heavy lifting. It moves the data across. So if you're moving data from Event Hub to basically HDInsight on the side, you will basically move it through the data plane. The beauty is that you can deploy this data plane in any environment. It could be on a VM, it could be on a Kubernetes environment, it could be on-prem, it could be running anywhere in specific regions. So pretty much it is running inside the tenant where the customer tenant is located, which basically means the data never leaves the customer's tenant and comes to StreamSets in any fashion, which reduces a lot of the data movement or data related compliance and security risks, which we don't want to take. And that's what basically the architecture which the Fortune 500, Fortune 1000 type of companies like. On the back end, our control plane actually runs as a SaaS service. We are a SOC 2 compliant service. We are in the process of getting a high trust certification from a security point of view. We are currently getting deployed into various regions. Our next iteration of our product will support region-based deployments and policy-based deployments across, which will enable customers to support GDPR capabilities or GDPR requirements in a more efficient fashion. Tom, you want to add to that?
Yeah. To add to that, the separation of the control plane and the data plane is really key there, right? So being compliant with GDPR, as you said, the data plane's moving it. So when you deploy the data plane, you obviously would deploy it in Azure, and you would have a variety of different ways of security measures that you want to take place on that. Within the control plane, we take full advantage of additional Azure features like Azure Secrets, work with things like Azure Active Directory. So the control plane has very little that it's doing as far as when it comes to moving the actual data. In addition to that, we also provide a variety of data protection processors out of the gate that provide additional data protection and automatic detection of PII data. So further protecting your data fully when you're creating those data pipelines.
Awesome. Thank you so much. So we actually had a couple of questions come in basically around how quickly can StreamSets deploy a data pipeline, or how long does it take to deploy StreamSets? So Tom, do you want to touch on maybe a little bit about the process involved with deploying StreamSets and how quickly a customer can get up and running?
Yeah, so creating and deploying a pipeline can take minutes, right? So I mean, this is a process that if you're a typical data developer, you're used to days or hours, right? So now we've gone all the way down to minutes. As far as deploying StreamSets, we offer a variety of different deployment methods. I think there's AKS, right? All the way down to simple RPM or Docker image, right? So you could deploy StreamSets on a machine in a matter of minutes as well. So it just depends upon how all the different components that you need to integrate with it. So it's less so about deploying the actual application and more so about integrating it.
And I'll add to that. You forgot the most important one. We support VR available on Azure Marketplace.
Oh, yeah. There you
So
go.
basically, you can do pretty much a one-click deployment, and it's a one-click start. And can consume it in a consumption-based model. And the beauty is that you can run some of the, and again, this is the data plane product. So you can run the data planes in Azure Marketplace, but then integrate it with the control plane. So you could run some of these data plane instances on Azure Marketplace, and some of them could be running on-prem. So supporting elastic executions, things like that, makes it a lot easier. So we support almost all deployment configurations you can think of.
Awesome. Great to hear. Yeah, Joey, I think you spun up an entire instance for me when you first demoed StreamSets to me. So
Yes.
I've definitely seen the ease of use. So we only have about a few minutes left, but we just got a question that came in that I think is a really great one. Does deploying workloads to Azure require rewrites for getting up on?
Yeah, that's a great question. I'll go ahead and tackle that. And that is absolutely one of our great advantages, is that we don't require rewrites of your pipelines. So if you're writing to, say, AWS or GCP, and you need to go back and actually deploy over to Azure, you don't need to rewrite your whole pipeline to do that.
Awesome. And then, Joby, real quickly, do you maybe want to touch on typical targeted customers? I can give you 30 seconds.
Okay. So our typical target customer is basically, from a persona point, it is the data engineers. So, the data engineers are building data platforms. Typically, we are in the Fortune 500 to Fortune 1000 type of companies where there is a complexity of deployments. They are generally typically enterprise customers who are building applications and have complex problems where they have a complex topology in which they're deploying data applications.
Awesome. Thank you so much. So before we run out of time, I just want to thank everyone again for joining us. Joby and Tom, thank you so much for coming in, answering questions, sharing your expertise. And I want to remind everyone to check out the links that we posted to learn more about StreamSets, as well as check out the links below for upcoming episodes of Ask the Expert. So once again, thank you so much, everyone, and enjoy the rest of your day.
Thank you, Matt. I appreciate it.